Hi, everyone. Welcome to the Neo4j online meetup. Just a couple things before we get started. For maximum visibility of the video, we suggest that you set your resolution to 720 megapixels. You can adjust it on the bottom right of the video. Also, if you have any questions while you're watching this presentation, you can ask it on the live chat that is on the right-hand side of the video. And if you're watching after the live stream is over and you have questions for the presenter, you can actually go to the Neo4j community site. David Allen has posted a topic thread where you can ask questions there, or you can reach out to him directly. And Mark Needham will be posting it in the chat. Also, if you enjoy the presentation, please give it a thumbs up on YouTube. Next Wednesday, January the 15th, we will have topic extraction on Meaning Cloud and Graphilian with Tom Zeppenfelt. And also, if you're interested in presenting for one of our online meetups in the future, you can also post about your project in the Neo4j community site under projects or the content categories. So let's get started. I am Corrine Wallach. I am the community manager at Neo4j. And I am here with my colleague, Mark Needham. Would you like to wave, Mark?
Hi.
Mark is the developer relations engineer at Neo4j. And today with us, we have David Allen, who is the partner solution architect at Neo4j, and he will be presenting on his project, Halin. So David, do you want to tell us about just give us some background about yourself, how you got to Neo4j and what made you start the project?
Yeah, I'm David Allen. What I do day to day at Neo4j is to work with some of our strategic partners, and I have a pretty fun job because I get to think partially about the business impacts of graphs, and partially I get to build fun stuff. And so I work on some of the cloud images that we publish on Amazon, Azure, and Google, and generally Neo4j systems integrations.
Nice.
So should I take it from here, Corrine?
Sure, take it from here.
All right, let me see if I can share my screen, and Corrine, let me know if this is coming through.
Yep.
All right, let me close off YouTube. All right, so thanks everybody for taking the time today. This is going to be just a couple of slides and some background motivating kind of information, but most of the session today I want to spend doing a demo and talking about how Halin works, what it can teach us about our Neo4j setups, and how we can get value out of it. So let me first start off by talking for a minute or so about why I did this. Halin is just kind of an open source project that I put together on my own time, something that I had always been interested in seeing Neo4j have. And the reason that I wanted to do it was to help organize a lot of the diagnostic information about Neo4j into a more visual form. Some folks may not be aware that Neo4j provides a whole lot of internal metrics and measurements, and we're going to get into how that works, that lets you know about the database and your cluster health and its performance. However, some of those metrics are exposed in a way that requires you to use a stored procedure, or that requires you to know something about the configuration file. And I just wanted a super easy overview way of seeing all of that information in one spot. The second motivation for it was that when we're providing support to customers, we tend to see some really common misconfigurations or errors that come up again and again and again. And so enterprise customers of ours that work with customer success, it's a very common thing that if you're running into a problem with your Neo4j cluster, the very first thing that they'll do is they'll ask you for a copy of your configuration file, and they'll ask you for some of your recent logs, and then maybe ask you for the output of some things so that we can diagnose some basic stuff. And so with Halin, what I wanted to do was create a way that we could capture that information really quickly and easily and provide any user feedback about the most common problems that crop up and how to solve them, so that it's basically like capturing some of the best practices that have come up through Stack Overflow, through the community site, and through our own support team. I mean, the third reason is just to help folks improve their understanding of how the database works and what happens when you put different kinds of loads on that database and how it responds to different configurations. And then finally, we're going to talk a little bit about graph apps in Neo4j desktop. And one of the things that motivated me to do this was to contribute back to the Neo4j desktop community by packaging something as a graph app and making it super easy to use, even for first-time learners with Neo4j. So before we get into the demo, I just want to give some really quick instructions on how you can install Halin as a graph app. So anything that you're going to see me do today, you can do on your own. If you install Neo4j desktop, this is a client application that lets you create your own databases locally and run Neo4j browser. It has this little tab on the right-hand side, the little four icon pane on the left where the first red arrow is. That's where it shows you a set of installed graph apps. And so Neo4j desktop can be augmented with a lot of additional tools that are available that interact with your Neo4j graphs. To install Halin, all you got to do is take the URL that is at the very bottom of this screen and plug it into the install graph application. And basically, graph apps are packaged as a JavaScript program or a JavaScript module, much as you would get something from npm.js. If you're familiar with that, that's how a graph app is packaged. You click install, and then Halin is going to be available within Neo4j desktop. The second option that you have is that Halin is already published to this public URL. And so if you don't even have Neo4j desktop, but you do have a Neo4j instance running somewhere inside of your organization, you can launch it straight from this URL and plug in your username and password to authenticate to that. Now, this is a web application that runs entirely in your browser. So although you're accessing a different site, there's not really much getting sent back to Neo4j unless you opt into that. Basically, this is all going to be JavaScript code running inside of your browser. And so if you have either a local host reference on your own machine or a reference to a machine that's only visible on your network, it's still going to be addressable from this website.
So we've just to say, we've put all those links that David's mentioned. They're in the live chat on the site. So if you want to play along with the talk, then feel free to take a look there.
Thanks. So over here, what I've got is a simple Neo4j desktop project that I've called Graph App All the Things. And I've created a sample graph here called Testy McGrapherston, and you can see the stop button going that this database is currently running but empty. And normally, if I didn't have Halin installed, you would basically see a screen like this, and I would click Add Application, and then I'd get a little Halin tile, and I'd just click Add that, close that window, and now within the scope of this project, Graph App All the Things, I've got access to run Halin. So since my graph is already running, I can just click on the Halin tab and it will pop it up. And so I'm going to give a brief overview of everything that you're going to see in here. And we're going to cover how that applies in Neo4j desktop and then talk about how it works with clusters. So the first tab that you get to is an overview. And so we can think of any kind of a graph running as a cluster. In this particular case, this is a cluster of a single machine. This graph is running only on localhost. And so what you see on this front screen is most of the most critical performance monitoring things that can give you kind of a single overview of what's happening with your database. These graphs are ticking along at roughly 1 update per second. And so as different transactions are coming into the graph and as it is allocating memory to the Java heap, you'll see that tick along. The second tab here goes into the breakdown of a particular machine. And so now we're not talking about the Neo4j database anymore, but we're talking about the performance of this one particular machine that participates in the cluster. If I hover over this little green box, it will tell you that this database is in single mode, meaning that it's a standalone Neo4j instance, and that we're polling it with 9 data feeds at present. It's taking up the observations as it gets them and giving you some time feedback. And then you've got this green dot because the node is fresh and online and responding well. So no status concerns here. In all of these graphs, you can click on the legend. So for example, the system load is what the operating system is doing, and my machine is under some load right now, and the process load is what Neo4j is doing, which is pretty much idle at the moment. By clicking on the legend, you can dismiss and re-enable any of these labels. Within the configuration tab, we can see how Neo4j is configured on this one particular machine. So if I go in here and filter, let's say I want to know what my heap is. I can just type in heap and it'll say, well, in Neo4j desktop by default, databases have a 512 megabyte heap. When you're diagnosing issues that may come up in the running of a graph, you're going to typically take a look at heap and page cache very early on for performance tuning, because it controls how much memory the database has to play with, and that's a huge factor in how well it performs. On the operating system tab, you're going to get basic operating system stats. So this is the physical memory of the machine. This is not about how much is allocated to Neo4j, but it's about the operating system as a whole. This particular machine has swap memory in use, and then there are a certain number of file descriptors that you can open maximum and what's currently allocated. This also shows you the disk allocation. So I can break it out and say, how much disk am I using to store nodes or relationships or properties versus how much disk is being used to store my graph total. Finally, on the data table, you can see that this is the total node count. So it's just a really rough metric of how big your database is. And so if you're running, let's say, a bulk insert operation, you can see this tick up. This tab here also will give you a list of your installed functions and installed procedures. So for example, I can type in APOC here, and I can quickly see that I have all of the APOC procedures installed. This database has APOC installed as a plugin. For those of you who haven't checked out APOC, I would definitely recommend that as a separate thing. APOC stands for Awesome Procedures on Cypher, and it's a library of procedures that you can add to any Neo4j database that gives it a lot of additional functionality folks really like. So let's see, on the user management tab, here we basically get a simple GUI to create users. Let's create a user called my tester, and I'm just going to put in a long password for it. So we've created the my tester user here, and I can click on manage roles and say that my tester should be assigned the roles of architect and admin. Click OK on that. And so now we can also administer roles. For example, we can create new ones to assign to users, or we can delete roles or reassign as needed. So one of the things that Halin will not let you do is it will not allow you to delete an administrative user, and it will not allow you to delete a built-in system role, which pretty much makes sense. So that brings us to the diagnostic tab, and this is one of the most fun things, or the thing that I'm most interested in Halin. At the top, it just kind of gives you simple summary. What is this database? It's running in the single mode. You are logged in as user Neo4j, and I'm running enterprise version 3.5.1. This diagnostics function, though, is really important. When you click the Run Diagnostics button, what it does is it gathers a lot of information about your entire setup and your configuration, and it then gives you an advisor view. This advisor view says for each machine in your cluster, it gives you a list of informational messages, warnings, passes, and errors. So let's look at the good news first. So Halin checked and said, well, hey, you configured your memory settings, and that's good. And backups are enabled, but only on localhost. That's important because you don't want to expose your backup host to the entire internet. That can be a security risk because people can exfiltrate data if that's the case. You want to have admin users specified, and that was certainly the case. We want authentication and authorization support enabled, and that passed. And every machine in this particular cluster is running the same version of Neo4j, which is good and expected. So let's look at some errors. Now, nicely, Neo4j Desktop has set it up so that when you create a database, it's already pre-configured really well. So we don't see any errors here. When we switch to the clustered view in a second, I'll show you some of the errors that can crop up in clustered configs. Let's see if there's any info messages here. This message is dealing with the port for the backup service. And any warnings? Let's see. At the time of measurement, my memory utilization was very high. So this is not really a critical error, but if you remember when I showed you on the operating system tab, my machine was just about pegged for memory. And so if you're trying to get the best performance and elasticity out of Neo4j, that's probably not a good thing. There's also here a warning about a page cache setting. If your page cache is more than 50% of your on-disk size, then you might be allocating too much memory to your machine. And the suggested action in this case is that you could actually reduce that. Another warning is that since the database is empty, obviously I have no indexes defined, and that's okay. All right, so that is running. That's a really quick overview of running Halin inside of Neo4j Desktop for a single machine. Now, on the website, I want to switch to what it looks like if you're dealing with a cluster. So here I've got it connected to a test cluster that I operate. And on this overview, you're going to get 3 lines instead of 1. And so you can see the heap size of all 3 of these nodes. All of these lines are completely flat right now because nothing is going on the server. So what I'm going to do in the background is run a little stress testing script. All right, let's see.
Your machine is not going to be happy with you now, is it?
Whoops, this is not working quite as I expected. Aha.
Writing to the follower.
Okay, so what I need is I need to configure the URL to be.
You got a typo in the export. I think.
Exprot.
All right. Let's see. Bolt. Sorry about this, guys. We'll be through it in just a second. There we go. So this in the background is just a little load testing script that I use. And the only reason I'm doing this is to start to perturb these lines over here and kind of show you that it's monitoring this stuff in real time. And so again,
what does the script do?
This particular script. So let me just pull out a section of it right here. What this is doing is it generates variable workloads on Neo4j that I use for testing. And so it's running 100 concurrent queries. So it's basically sending a batch of 100 queries at a time to the server, broken into different strategies. And so I have a raw write strategy, which is just basically like I'm writing a couple of simple nodes. Random linkage is that it pulls 2 random nodes out of the database and creates a new relationship. An aggregate read is just what it sounds like. It's a cipher query that performs some aggregate. A long path read is where you're doing a long variable path link operation in Cypher. And so basically, like by tuning what kinds of queries run and how frequently they run, I can simulate different kinds of load on the server. Does that make sense, Mark?
Yeah.
Okay.
Cool.
So, and you can see the heap size on node 1 and node 3 is ramping up, and node 2 is just kind of jittering down there. In terms of transactions, you can see that, check this out, node 2 is handling the most transactions, and node 2 has the star. It is the leader in this cluster.
So maybe should we do like a quick crash course in what does that mean? Like what does leader follower mean?
So most folks who have run Neo4j in Neo4j Desktop, they're going to be running a single machine, and Neo4j Enterprise includes the ability to do a clustered setup. And so we call this product Causal Cluster. and you're basically replicating the graph across 3 different nodes so that it basically allows you to scale out how many read queries you can send to the cluster. Instead of having just one machine serving queries, I have a cluster of 3 that are serving queries, and they all see exactly the same data with the ACID guarantees of the database. So when we think about the cluster as one gigantic database, but it is composed of these 3 machines. And so that's why Halin is giving you the overview tab that shows you cluster health, but allowing you to look into, let's say, node 1 and seeing how the system and process load and how the memory utilization on just node 1 is going. This star up here is important. In a clustered setup, a cluster always has a leader. The leader is responsible for taking all of the writes to the cluster, and it's responsible for coordinating the cluster, if you will. The other 2 nodes have the role of follower, which you can see right there. Followers replicate this data and serve read transactions against the graph. About my workload, I introduced something a little bit funky to this that I want to show you how you can see this in Halin. One of the things you'll notice is that node 2 is processing most of the transactions, and node 1 and node 3 don't really have much going on. Okay? This is indicative that the way that I've set up my workload is sending all of the load to the leader. Now, there's lots of ways that we can talk about in another session, another time, about how to spread that load out. But what I'm currently seeing is that I'm beating up my leader really hard, and my node 1 and node 3 are not really doing much for me, despite the fact that I'm doing a lot of read queries. And so we can visually see that in the workload as it's impacted here. So going over to node 2, you'll see its memory jittering around and the number of transactions that it's processing jittering around accordingly. Whereas if we go over to let's say node 3, it's just starting to pull right now, but it has a much flatter heap allocation. Similarly, if we were to look at the, let's say, operating system stats for these nodes, let's see, load or operating system memory usage, you would see it less on 1 and 3 and more so on 2. So this brings us to user management. User management is a little bit different for clusters. One of the things that some folks don't know about Neo4j is that the user management happens per node. And so if I go and I execute some cipher to create a user named Bob on node 1, it is not automatically replicated to node 2 and node 3. So one of the things that I did with Halin is made it possible to create users, create roles, and associate with them in a way that's cluster-wide. So I put this warning message up here because this is not entirely standard, but things that you do here apply to all machines in your cluster. So if I create a username Bob with a password of admin or whatever the case is, that's going to go for node 1, node 2, and node 3, and it will only succeed if it succeeds in all 3 places. Finally, a special thing about diagnostics on clusters. Keeping in mind, clusters are composed of multiple machines, so when you run the diagnostics, you're going to get a lot more data back, and you're going to see that the machines are all listed individually so that you can look at the findings on a per machine basis. So let's try to filter it down and say, what are the errors that I find on node 2? So because this is a sample cluster, I set it up to show some of these issues. Node 2 does not have an initial heap size or a max size configured. And that's going to be a performance bottleneck and cause heap allocation to happen in not such a great way. It also doesn't have a page cache size. Here's an interesting error right here. Machine is missing roles only here and Graph Connect, which are defined elsewhere in the cluster. That means that Halin has found that these particular roles are defined on that node and nowhere else. This can be problematic because if an admin defines a user or a role only on node 2, they then go to node 1 and expect to be able to log in there, but that doesn't work. So you might want to pick up on some of these and correct those. If we go to node 1, there's a different error, and if you go to node 3, it's a different set of errors again. Overall, though, you can filter it down to just the passes, and of course, we've got 2 pages of passing checks here because there are so many things to check across so many different nodes. If you want to see what goes into these diagnostics, you can always download the diagnostic package here. That is just a big JSON file, and so it's processable with any kind of tools that you would use for JSON. One other thing I wanted to note about the diagnostics on clusters is that you get a configuration diff tool. And so this is another common source of issues that we find. Let's say that I'm looking at heap configuration. I type in heap over here, and you can see that the values do not match. And it'll show you what the values are across the 3 machines. This guy has 4 gigs of heap. This one has 4,900 megabytes, and node 2 didn't have it specified, which that matches the error we saw on the previous screen, that it wasn't specified on node 2. Or what you can do is you can break that up and then just say, show me all of the spots where my values don't match, and it will show you the explicit differences between machines in your cluster. Well, their advertised addresses are all different, and that's okay. And the advertised addresses here being different is also not really problematic, but the heap and the page cache are all different, and that's a potential performance issue.
This is really nice for that type of thing. When I know lots of people can find themselves confused as to setting those different, like when they're setting up the cluster, what to put for those different addresses.
Mm-hmm.
So I guess they would be able to see more clearly what mistake they might have made by using this.
Yeah, absolutely. And sometimes we run into cases where the machines might be configured differently. Let's say you send a query to the database and it takes half a second to run. And then you send the query to the cluster again, and now it takes 5 seconds to run. That's really weird. Well, it could be that the machines are performance tuned differently, and that needs to get detected and ironed out. The advisor, though, is something that I'm going to be building more things into over time, in that the goal is to be able to just hit a button and get a lot of advice as a baseline about how close you are to best practices or things that you might want to improve or fix to get better performance out of your cluster. So that's kind of a quick run through on the clustered setup. Let's talk about one of my favorite topics, which is what happens when things go wrong. I want to actually break something and show you what that looks like when it breaks. So the most common, like, big nasty operational issues that are going to happen in your cluster are leader re-elections. That's when the cluster has to form a new consensus about who's in charge. You can have loss of contact with a node. For example, the operating system crashes, or you don't have network access anymore. The underlying database software restarts, or you get an out-of-memory error that some users run into. If you haven't allocated your database enough memory and you try to do a transaction that's bigger than the amount of memory that you have, then you can get these OOMEs that will potentially even crash and restart things. So to simulate this, here I've got, let me kill my, my load script here. All right. You'll see that I've got node 1 and everything's fresh and green, looking good. My cluster is in a good state. Nobody's thrashing or upset. Now node 2 is my leader. Let's do something very nasty. And what I'm going to do is SSH into that particular machine. And when this window comes through, what we're going to do is restart the master. So sudo systemctl restart neo4j. Now, I mean, this is a simple operational thing that you might do if you updated the operating system or what have you, but it's quite disruptive to the cluster because node 2 is going to suddenly stop existing. And so what we're going to do is run that, and you'll see in Halin over here, the star went red. That's because the system service on the actual machine just fell over. Now, over here too, you will also see that the node 2 line is just stopping and you're not getting any data anymore because the service doesn't exist. Now, as the system service comes back up, right now you've got this red star. The last time node 2 was contacted, it thought it was the leader. But you'll see that node 3 has now gotten a green star because it's been reelected as the leader of this 2-node cluster. Node 2 is still offline. As node 2 rejoins the cluster, we should start to see it pick back up and go green again. And when it goes green, it'll come back with a little bubble indicating that it has joined the cluster as a follower because node 3 is now the lead. So if we go over to the diagnostics tab, we'll also see that there's a cluster event log, and you'll see that there was a role change detected. So this was, and I need to fix this. This should give you the address of the node. But essentially, there was a node that had to step up from follower to leader because one of the other nodes in the cluster fell over. In the meantime, node 2 has gone green, and the data has resumed. And so now we've got a healthy cluster again with node 3 in the lead. Pop back over to the overview, and you'll see that node 2's data has basically straight lined across. This was the period of its inavailability. So that's how it's going to look when the cluster starts thrashing or gets into problems. If you hover over this, you'll see 11 of 11 fresh. And if your node performance degrades, it's first going to go yellow, and it might say something like 3 of 11 fresh. And that's just Halin telling you that your database is responding really slowly and it's struggling, maybe having performance issues. Green, everything's good, and red means nothing's fresh. I can't even contact this node. If you want further diagnostics, you can click on this little gear icon at the very bottom. And this actually outlines all of the queries that it's running and shows you a response curve. So for example, this is the query that I'm running, and this is the response information of how long it's taking that node to respond. This is way less than 200 milliseconds per response, which is great, healthy, normal, unproblematic behavior. Okay, so switching back over here. Whoops, wrong button. Well, let's talk a little bit about how this works and where I'm getting this data. At the very beginning of the presentation, we talked about how Neo4j already exposes a lot of these things. Halin isn't really doing anything new. What it's doing is just putting a user interface on top of what Neo4j was already giving you. So Bolt is the binary protocol that you use to communicate with Neo4j. If you write a program that talks to Neo4j, it communicates over Bolt. And because Neo4j is fundamentally a Java application, it gets to use this framework called JMX, the Java Management Extensions. And the way JMX works is that you get a series of managed beans, each of which has a set of methods. And so in JMX, there is a bean for the operating system. And you can call a method on that bean that gets you data about memory utilization in the underlying operating system. Neo4j provides 2 ways of getting at JMX. You can configure remote access. If you look at the documentation on the website, there's a way that you can expose JMX stats remotely and then configure a client to talk to that. And then the second is that you can get at JMX using Cypher directly by simply writing a query, call dbms.queryjmx, and giving it some parameters. It will give you the data real time. So here's an example of how you might do system load with JMX in Cypher. You call this stored procedure, and you give it the name of the mbean that you're interested in, which is operating system. And then it gives you a bunch of attributes back. And the with section here is me just destructuring that data so that I can return 2 simple metrics, system load and process load. And this is not a hypothetical query. This is exactly what Halin is doing against your Neo4j instance. And these 2 values, system load and process load, are what's going into the graph that you saw in the demo. Just about all of those graphs are generated the same way. They're done with polling Cypher queries against the database. And what's nice about that is that it gives you this pure Cypher, pure Bolt interface to the database. There's no plugin to install. There's nothing to add or change to the configuration of the database. It just works out of the box as long as you have an administrative user that you can use to log into your system. There's a couple of things that Halin won't do that I wanted to cover briefly, and we'll give you some alternatives before we get to Q&A, so that you can have a more comprehensive approach if you're in an enterprise monitoring setup. What Halin doesn't do is real-time alerting. So this is good for diagnosing and looking at particular load patterns and trying to find problems with your workload, like what I showed you earlier where I wasn't sending the right queries to the followers. Real-time alerting is a slightly different use case where, say you have a transactional database that runs 24/7, and what you want to do is whenever the memory utilization gets above 90%, you want to have an admin inside of your company sent an alert to go look at something so that the database doesn't fall over. Halin is not going to do that because it's running entirely within your browser. There are, however, a lot of other services that do this really well, and I'm giving 3 examples here, but there are a zillion of these guys out there, and it's not just these 3. Essentially, what you need to do in that scenario is to package your JMX metrics, or package them, or use Prometheus as an endpoint, as a set of endpoints, and ship this metric data over to a third-party service like Grafana or Stackdriver. They then provide you the dashboards and the automatic alerting capabilities. And that has a very different use case than Halin, where you're not going to sit there and watch it tick along, and it's not going to give you deep insight into your Neo4j configuration or help you diagnose issues, but it will do that 24/7 hands-off automatic type monitoring. So if Halin isn't your thing, but you really want to get into this metrics and monitoring thing, I'm going to provide these slides in a link on YouTube when we're done with this. But there's an article on Medium called Neo4j Operational Dashboards with Haudio. Haudio is a web-based application where you can build dashboards for anything that reports JMX. And that article steps you through how to ship JMX metrics to Haudio so that you can do that within Haudio. There's another article that we'll link, which is shipping monitoring metrics with Prometheus. And so if you're using another tool like Datadog or others, many of those are built to integrate nicely with Prometheus, and Neo4j already exposes Prometheus, so you're in good shape. Finally, if you are an enterprise customer of Neo4j's, we have in our private knowledge base a set of articles, I believe, on Grafana dashboards. And so we have some JSON dashboard stuff for Grafana that we can provide out of the box that gives you a nice dashboard of what we consider to be relevant Grafana metrics for Neo4j. And with that, I think that's the demo. I'd like to open it up for Q&A. Mark, can you tee up some of those questions for me?
I can indeed. First comment we've got is less a question than some compliments for your office setup and enjoying the musical backdrop.
I feel like most of the commentary in the chat is comments, people saying how awesome this is and how many things it can be applied to.
Well, thanks. Well, thanks for the musical compliments, by the way. Like, I love music, but yeah, can't live without it. Is there a question there, Mark?
There's not a question there at the moment, but people tend to be a little bit behind us, so I'll give them a few seconds. I guess okay. I can ask you some things while we're waiting.
Sure.
So is all the stuff you have that you display at the moment, is that all basically from polling Neo4j via the procedures?
Yes, 100%. And the polling approach is not always optimal for everything, but the reason polling works so well for Halin is that it gives you a moment-by-moment representation of how respondent your cluster is. Yeah. And the other really nice thing about polling with pure Cypher is that, like I mentioned, no plugin, no extra configuration, no nothing. You don't have to do anything. It works with desktop out of the box. It works with any database that, I've tested this with 3.4 and above. Some folks might have issues with earlier versions of Neo4j, but if you're using 3.4 or above, it just works.
Yeah, so is there any use case where you wouldn't want to do the polling approach, or you found that generally it doesn't really add that much load to a running system that it's fine to do that, take that approach?
In terms of load, it really adds negligible load.
Okay.
Let me see. It's actually measurable though. Like if nothing is happening on my cluster, let's
Mm-hmm.
take a look at. Okay, so 200M is. Let's actually go into one of those things and see how hard it's working. But this would be a load of 1.0.
Yeah.
Okay, so this is the process load of Neo4j when it is doing nothing other than subjecting itself to Halin's load is minuscule. And in terms of memory,
Yeah.
I can probably get some stats for you, but yeah, it's consuming right now. Neo4j was consuming 5% of CPU. So the other thing to keep in mind is that a lot of the metrics that we're pulling are stuff that the Neo4j database process may keep in memory anyway. And so, like, for example, if you ask it for its configuration, it had to have that in memory anyway. If you ask it for JMX, some of that is already there anyway. So the database isn't really doing a whole lot of work to respond to these queries.
Oh yeah, no, I just know that's a thing that people sometimes
Yeah.
find interesting when they hear about monitoring tools. Because I guess the other approach, as you showed in the, I think it was the last one of your alternatives, the Grafana stuff. I think you're kind of doing it the other way around, where stuff is being streamed out and you're just
Yes.
taking it and putting it somewhere else.
Absolutely. Every once in a while, you'll see this like spike in process load, and I would bet that that corresponds to a garbage collection operation. So one of the things I didn't cover in detail is the GC pause. So Neo4j allocates memory in this ongoing way, and then periodically it will pause to do garbage collection to free up available memory. And so if your database is under load, occasionally it'll pause to reclaim memory. If you see GC pauses that are taking a lot of time, right now mine are taking 20 and 30 and 50 milliseconds, then that's also indicative of a performance issue. But that can cause a spike sometimes, but it's super momentary, as you can see.
Okay, cool. We have suitably stored, but we now have a question.
We have a couple of really good questions coming in.
I guess, so one of them, I think we've already answered it, was can you comment on the workload put on the cluster by polling? So I think is there anything extra that you would add about clusters, or is it covered already?
The only thing that I would mention is if you want to see the guts of what it's really doing, click on this little button down here, and it's going to give you a breakdown. Okay, you'll see that this node1 follower is getting the cluster role query, and you can see exactly what I'm executing against that database. So call dbms.cluster.role. And if you're into this sort of thing, you want to learn more about Neo4j, you can just have a look at some of these queries that I'm executing and then go back to the documentation to see what they mean, and you can learn a lot about Neo4j in that way. But so this particular query, you can see its best, average, and worst response times. And yeah, everything that we're running is in this list. So if you wanted to check for yourself, how much of a beating does it put on your machine if you try to calculate your store sizes with JMX, then you can dig that query out and try it yourself.
Cool, great. Okay, next one we've got is from Nicholas. So he's asking, how would you go about installing Halin if you wanted to run it in an isolated data center without external network access? What would be your deployment approach for that?
Well, what I would do is, okay, we should paste this link in, the GitHub link, Mark.
Yeah, I'll do that.
You put that to the channel when you get a chance. So there's kind of two ways that you can do this. We provide a Docker container. So mdavidallen/Halin latest is on Docker Hub, and you can just run it directly as a Docker container. The other thing is that you can install it as a standard JavaScript app, and by yarn install, yarn start. In the Docker file, if you're into the whole Docker thing, it will give you instructions on how to set this up so that, look, in the end, this is just a static set of resources. When you go to halin.graphapp.io, you are literally getting the contents of an S3 bucket on Amazon. So this is just static HTML and CSS. So to run this inside your own organization, all you really need to do is run the build. It produces those static assets, and then you host those wherever you want internally, and you're done.
Cool. All right. Next question. Although I'll see if I'm going to interpret what I think it meant. It was asking, can you monitor two different Neo4js? I'm assuming this means like kind of two standalone Neo4js. Is that like, could you point it at two different ones?
Well, so yes. I've not tried that inside of Neo4j desktop, but like let's just try this on the site for a second. So I've got my cluster monitor, right?
Mm-hmm.
And let's pull up a second one. And over here, oh yeah, I'm already running this graph on localhost. I never stopped. So I'm just going to type in localhost. There we go. I've got my cluster over here, and I've got my single node desktop install here.
And so when you set up the Halin on the cluster one, what did you fill in as the credentials there? Do you just put one of the nodes and it goes and picks up, hey, actually this is connected to other things?
Yeah, so all you need to connect, and I'm sorry, I didn't actually show that step, is when you go to halin.graphapp.io, this is what you're going to see, just a connection dialog. I mean, again, this website is not contacting your database. This is all code that you're running inside of your browser. So you basically fill out the URL of any of the nodes in the cluster, the port you want to connect on, and this is making a pure bolt connection. So it initializes and then it starts up. And now if you have a causal cluster, folks may be familiar with the idea of bolt plus routing. So it doesn't really matter what URL of which node you give me, because if it participates in a cluster, Halin is going to ask, hey, are you part of a cluster? And if so, it's going to discover the URLs of those others without needing to be told. Now, one assumption that it is going to make is that in order to pull those other nodes, it's going to use the same username and password that you gave it. So if you say, I want you to log in as Neo4j, password foo, and I want you to connect to node 2, then it's also going to try to connect to node 1 and node 3 with that same username and password. So this could go wrong, for example, if the user had different passwords on different nodes, but I mean, as we covered in the diagnostic section, that would probably be a misconfiguration anyway.
And obviously they should be configuring their user management from Halin anyway, so then they'd be fine.
Well, it's something that I find convenient, but you know, I should provide as a disclaimer, like, this is open source that I wrote, and I'm really happy to see people use it and get value out of it. But it's not right now part of the official product surface of Neo4j. So when I say it's good to use the user management in Halin, I'm saying that as David, not as a Neo4j guy, if that makes sense.
Yeah. Okay, next question. So this is from Michael Ennis. So first thing, hi guys, this is awesome. I'm having a problem upgrading my database from 3.4 to 3.5. Do you think I could use this tool to show me if I have any config errors? Obviously, it's a bit of a broad question, but
yes, absolutely. So if you have, let's just open it up and take a look at the config on some individual machine. Now, Halin won't do the upgrade for you. Obviously, you're going to need to do that separately manually. Once you do that upgrade, you can take a look at your configuration, and you can also run the diagnostics tool on it. Between 3.4 and 3.5, there were a couple of configuration settings that got deprecated and some new ones that became possible. So if you're doing a straight upgrade, it's unlikely that when you get to 3.5, you're going to have major problems that didn't exist before. I think when you get to 3.5, at most, I would say there might be 1 or 2 settings in there that are deprecated and don't really have an effect anymore, and there might be some other settings that you might want to consider, but the database is probably going to work just as well with 3.5 as it did with 3.4 using the same config, unless you're in a pretty specialized setup. So, I mean, You can't say that about all databases because some people use LDAP plugins, other people use all kinds of other plugins. So one thing that you might watch out for going from 3.4 to 3.5 is you need to upgrade things like APOC dependencies. The version of APOC that you run for 3.4 needs to be different than the one for 3.5. And so that's going to be a common problem people run into, is the need to, maybe recompile a plugin.
Okay, cool. Yeah, I think that I'm not sure exactly what's the issue that the person who asked the question is having, but perhaps we can follow up on that one on the community side afterwards and try and sort it out.
I've got this right up here, Mark. After this session, if you've got a question that we didn't have time to answer, or you're just wondering something, come to community.neo4j.com and ask the question. Maybe I can respond, maybe others. There are a lot of other really knowledgeable people out there who are super helpful.
And if it's about the Halin project specifically, we can also share a link in the chat now for that exact thread. So that way David will get the alert if you comment or post a comment or a question on that thread. So I think that's it, right? Are we wrapping up?
I think so, yeah.
Yep.
Thank you guys for joining us. Please join us next week. And, if you, like I said, if you are interested in speaking and for one of the future online meetups, you can post your project or your blog or content, whatever you have, on the Neo4j community site under content or projects. And you can also vote if you see something that you like inside of the community site under projects or content. You can just give it a like, and we'll consider it as for one of our next online meetups too. And you can also like the video if you enjoyed David's presentation.
Thanks everybody for taking the time today.
All right, thank you guys so much.
Thanks.
Thanks, David.
Bye-bye.